Today we are going to discuss some of the elementary number theory operations in cryptography. First, GCD, greatest common divisor, LCM, least common multiple, modular arithmetic. What are primes? Any positive integer p greater than 1 are called prime. If and only if positive factors are only 1 and p. p എന്ന് പറയുന്ന ഒരു നമ്പർ സപ്പോസ് ഇറ്റ് ഈസ് 7 പ്രൈം നമ്പർ ആണെന്ന് പറയണമെങ്കിൽ the 7 has only the factor as 1 and 7. A positive integer which is not prime are called composite. Every positive number can be written uniquely as the product of primes, where prime factors are written in the order of increasing size. This is very important rule in cryptography. Every positive integer can be written uniquely as the product of primes. ഏത് പോസിറ്റീവ് ഇൻറ്റിജർ എടുത്താലും we can write the product of some prime numbers. Examples: 15. A positive integer 15 can be written like this: 3 into 5. Both 3 and 5 are prime numbers. Again, the number 48 can be written as 2 into 2 into 2 into 2 into 3. That means 2 is multiplied 4 times and then it is multiplied with 3. So every time we are multiplying with only prime numbers. So 48 can be written as 2 raised to 4 into 3. Then the number 17. 17 itself is the prime number. So we can write it is 1 into 17. Then 100. We can write 100 as 10 into 10. That means 2 into 5 into 2 into 5. That means 2 square into 5 square. So again it's the product of then 5 12 can be written as 2 raised to 9, that we know. 15 can be written as 5 into 103. The 28 can be written as 2 into 2 into 7. Then least common multiple. How to find the least common multiple? We know that least common multiple is the smallest common multiple that is divisible by both numbers. So LCM of of 37 is 21. LCM of 46 is 12. LCM of 510, it's 10. And actually this is applicable. This method is applicable only for small numbers. How to find LCM using prime factorization method? So any number, we know that any number can be written like this: a is equal to the product of some prime numbers. Here the in positive integer a can be written like this: p1 raised to a1 into p2 raised to a2, etc. up to pn raised to an. Similarly, the second number b can be written like this: p1 raised to b1, p2 raised to b2, etc. up to pn raised to bn. p1, p2, etc. up to pn are prime numbers. p1 less than or equal less than p2 less than pn. Each ai and bi are elements of natural numbers. Then For finding the LCM of AB will be P1 raised to maximum of A1 B1 into P2 raised to maximum of A2 B2 up to Pn raised to maximum of An Bn. Suppose our the first number A is 60 and the second number B is 54. First number 60 can be written as the product of some prime numbers, that is 2 raised to 2 into 3 into 5. Similarly, the number B54 can be written like this: 2 raised to 1 into 3 cube into 5 raised to 0, that is 1. So LCM of AB is equal to maximum of these two, that is 2 raised to 1 and 2 raised to 2. The maximum is 2 raised to 2, and considering the case of 3 raised to 3 and 3 raised to 1, so the maximum is 3 raised to 3, and 5 raised to 0 and 5, the maximum is 5 raised to 1. So the LCM of AB, that means LCM of 60 and 54 will be 2 square into 3 cube into 5, that is equal to 550. So LCM can be written like this. Next one, GCD. How to find GCD? This is actually finding GCD is important than finding LCM in the case of cryptography. P1 raised to, in this case also, the number first number is written like this: A is equal to P1 raised to A1, P2 raised to A2, up to Pn raised to An. B is equal to, second number B is equal to P1 raised to B1, P2 raised to B2, and up to Pn raised to Bn. Here the P1, P2, Pn are prime numbers where P1 less than P2 less than Pn. So the GCD of A will be, in the case of LCM it is maximum, but in the case of GCD it is minimum. That is P1 raised to minimum of A1 B1, P2 raised to minimum of A2 B2, Pn raised to minimum of An Bn. So A is equal to 60. That is equal to 2 square into 3 into 5. B is equal to 54. That is equal to 2 raised to 1 into 3 cube into 5 raised to 0. So GCD of AB is equal to 2 raised to minimum, that is 1, 3 raised to 1 and 5 raised to 0. So the GCD will be 6. Then what is relatively prime? Relatively prime means if two integer numbers are relatively prime if GCD of AB is equal to 1. Are 50, 80 relatively prime as GCD of 15 and 28 is equal to 1. And 55, 28 again it is 1. To 35, 28 no, because GCD of 35, 28 is 7 not 1, so they are not relatively prime. These relatively prime numbers are always called co-prime numbers. Thank you.